So it is because of the molecule attract each other, atom attract each other, they are neutral. They attract each other when they are slightly apart. This was explained, both things was explained attraction and repulsion in quantum mechanics. When we learn about quantum effects, then its value was calculated and one knew quantitatively what is the nature of these interactions. It is called electromagnetic. It is because it is due to the motion and distribution of electrons. I'm not going to explain quantum mechanically how it arises, but it is a quantum mechanical. We explained it learning quantum. Now coming to the second point, that how atom, when hydrogen atom, another hydrogen atom come close to each other, then they form molecule. How this molecule came into being? अरे आगे बैठ जाओ ना. How these molecules are formed? Oxygen atom, they come close to each other. They form a stable molecule. It is a neutral atom, They are coming close and form it is not van der Waals formula. They form molecule. Molecule with certain energy, unless you supply that energy, they remain in molecule. On the oxygen or the nitrogen in the form of molecule, nitrogen in the form of molecule. You have to heat it to very high temperature to break it into oxygen. And atom form and heat further to ionize it. Can anyone explain? Hello?
सर बेसिकली उसमें एनर्जी लेवल्स मतलब जो एनर्जी जो होती है स्टेबल हो जाती है एटम्स जो H2 को मोनो एटम के फॉर्म में रहते हैं तो उतनी स्टेबिलिटी नहीं होती है.
क्यों नहीं स्टेबिलिटी होती है?
स्पिनिंग इफेक्ट एक दूसरे को कैंसिल नहीं करते हैं.
एक ऑक्सीजन एटम स्टेबल है.
नहीं सर, पैरामैग्नेटिक है ना एटम.
सर एंट्रोपी इंक्रीज हो जाता है तो ऑर्डर.
हाँ, अब रिसर्चर्स फॉलो बोलो. पीछे से मैंने पूछ रहा हूँ. Again, it is the quantum mechanics. Say hydrogen atom, you take another hydrogen atom, one electron moving around the. So one thing I missed it. Okay, I come back. So this proton and electron is angstrom region moving here, another is here. When they come together, okay, it is one electron. Here Pauli exclusion principle not playing role. Pauli exclusion principle is not playing role. Pauli exclusion principle, all the quantum states are filled. So first orbit, which is called Bohr orbit, can accommodate two electrons of opposite spins. So one atom, each one electron of opposite spin happy with that. And another atom comes with one electron with an electron, opposite spin, they share with each other. So if you calculate by quantum mechanical equation, have you heard Schrodinger equation?
Yes. Yes.
What is her name? Sorry? Leona. Have you heard Schrodinger equation? Yes. So it tells you the wave functions, and evolution of wave function, etc. you calculate wave function and then the density of electron on the wave. Wave function is the probability of finding the electrons. So you solve Schrodinger equation and calculate the probability of finding them. Then between the two atoms, the probability electron concentration is more than other side. So that bond make the binding between the two. Blue. But before quantum mechanics came, some people speculate. Sometimes speculation is right, as what the law said, and sometimes speculation is absurd. So they thought before quantum mechanics that atom has some kind of hook and some kind of sense of knowing the hook. So when they hook mass, then atom is formed. That is speculation, guessing, and it was absurd. But then nothing was known. So again, when quantum mechanics came, we learned how atoms are, molecules are. And whole chemistry is based on it. They go on making bigger and bigger and bigger molecules and see the properties, etc. Now coming back, let me another thing. Now the question I raised, but then I set it to other. In the atom, if you look for the electron, where they are lying? Are they moving on what is called Bohr orbit? Hello?
क्लाउड के जैसा
हाँ क्लाउड
First, take the opportunity to participants. Are they moving on the Bohr orbit? Yes or no? Irina, do you know? Can you guess? Are they moving on the Bohr orbit? So why, you know from your electricity paper or electromagnetic study, that any charged particle get accelerated, making accelerated motion, then they emit radiation. You know that? Now if electron is moving on the orbit, it is accelerated motion. Orbital motion is accelerated. The electron will emit radiation and lose energy. All on the program, atom will not be stable and we will not be here. We will not be on there. Earth will not be there. So what was wrong?
क्वांटाइज होता है
Sorry?
एनर्जी जो होता है वो क्वांटाइज होता है वैसे लूजिंग एनर्जी
यहाँ ऑर्बिट की बात कर रहा हूँ.
So the electron cannot move in random orbits. It has some specific momentums. Bohr has given
So Bohr was wrong. Niels Bohr was wrong.
Yeah, in future he collaborate with Summerford.
This was the contradiction. Bohr said, we don't know what is happening. It is something we don't understand it. But he made a model, which is called Bohr model. That electrons are moved. Why he assumed it? What was the compelling reason for him to think about it? First was nucleus is at the center, occupying a very small region. Atom is moving all around. So how the electron is moving? But he knew there was one experimental result which was interesting to him. If you record atomic spectra, if you have a gas and you allow this light to pass through it and you record, then you see some black lines. These black lines is because those particular wavelengths are absorbed by the electrons. Reverse experiment is that they have atomic gas and you make the light to fall on it. You heat it. You supply some energy to it so that electrons go to higher orbits, and when they come to lower orbit, then they emit particular lines. The spectrum lines are there. So how to understand it? So he said that there are orbits. On those orbits, because of mysterious force or mysterious reason, electrons do not radiate. Radiation is not emitted. Otherwise, it is emitted. And when electron jumps from lower to higher orbit, he calculated the difference. Then that radiation, H knew the frequency of that radiation, will be absorbed. Explain the experiment. Reverse is that if it comes from higher orbit to lower orbit, the energy difference will be emitted. It is explained, but fundamentally it was wrong. Agreeing with experiment is no guarantee that your theoretical concept is right. So this is the questions which bother. So D. Roy came out and he said, he postulated that electron has a wavelength associated with it. When on a particular, those orbits where wavelength integer number is there, it starts from here and it comes here and joins. Then those orbits are stable, otherwise not stable. But again, not. Again, it is the quantum mechanics. It is not orbit. Electron is not moving on the orbit. Electrons form clouds along the nucleus, and these clouds have discrete pattern. If you have heard orbitals, yes, orbitals it is called, where spherically symmetric cloud. P orbitals lobes along x-axis, y-axis, z-axis. So sphere you will accommodate 2 electrons, Pauli-Exclusion principle of opposite spins, and second p orbitals you can accommodate 6 electrons, d 8 electrons, everything. जोर से जरा बोलो, नाश्ता किया हो कि नहीं?
हाँ, जैसे p ऑर्बिटल्स में सर इलेक्ट्रॉन जो होते हैं वो s ऑर्बिटल्स के इलेक्ट्रॉन्स के साथ सुपरपोज कर सकते हैं।
उसको कहते हैं हाइब्रिडाइजेशन। हाइब्रिडाइजेशन की जहाँ सिचुएशन होती है
मॉलिक्यूलर फिजिक्स
हाइब्रिडाइजेशन एडवांस। So why we use the word Bohr orbital instead? You find the Bohr orbitals, electron jumping from one orbit to the other. It is the common in the physics language. It is still we use Bohr orbits. Why we use it? When we know that electrons are not moving on a particular orbit. In quantum mechanics, basic principle of quantum mechanics, you cannot predict, you can only talk in terms of probability. So Taylor equation, when you solve that is the equation, you take the psi, and through psi you calculate the probability of finding the electron. So there is a word probability density. You ask the question, if this is a nucleus, at distance r, in a small spherical cell of width dr, what is the probability of finding them? If you solve the Schrodinger equation for hydrogen atom, you find the wave function exponentially decaying, its maximum value is at the nucleus. But electron is not at the nucleus. You might have read it or you will read it. It is a contradiction. Psi square gives you the maximum value at the nucleus. But you are asking the question in the spherical cell. The volume of the spherical cell is R square dr. At the nucleus, R square is 0. So multiply with R square dr, psi square equals 0 at the end. And R square increases, psi exponentially decreases, it has maximum value at the coordinates. The probability of finding the transpose was completely wrong, though his presumption was wrong, his theory was wrong, but still we find that if we calculate quantum mechanically, the probability density of electron is maximum at the coordinates. These are some simple concepts I tried to explain to you. You have read or you will read it, but you never pay attention to these simple things. And I bet you when you come for interview and ask these questions, you got a very, very solid figure. You might have published large number of papers in reputed journals, but you are not good as a teacher. Because you never explain the concepts to students, and those students as ignorant as you were